Good morning, dear students. In the last lecture, we have reached up to the process scheduling queues. So let us recall it. First is a job queue, then ready queue, device queue, and we know that the process migrate from one queue to the another. First, it is in a job queue. If it is ready for the execution, it will enter into the ready queue. If it needs certain IO operation, then it will enter in a device queue and so on. Okay. Now this is also here. Just see here. This is a ready queue. Head points to the first PCB and tail points to the last PCB. So there are many PCBs or the process are there which are residing in a ready queue. So this head means is the pointer or the address of the first PCB and tail means the pointer to the last PCB. Okay, so PCB 7 is the first process, PCB 2 is the, and here it is showing the null means it is the last process. Then this is the device queue. Device queue is magnetic tape. Magnetic tape is a device, unit 0. Okay, so this is one device. There are no process in a device queue, head pointing to null, tail pointing to null. Then magnetic tape unit 1, no processes are there, head pointing to null, tail pointing to null. Now this disk unit 0, here head pointing to PCB 3 and tail pointing to PCB 6. So there are 3 processes are there and PCB 6 is the last process. Then terminal means a keyboard or a monitor. So input terminal means a keyboard and output terminals means a monitor. So there is only one process. So head is pointing to PCB 5 and tail is also pointing to the PCB 5. So only one process is there and this is pointing to the null. Now how the process changes here, the process scheduling? See, this is a ready queue. In ready queue, the processes are coming from secondary memory which are loaded by the swapper into the ready queue. Okay. Now one of the process from the ready queue, it is selected by the scheduler. We call it as a CPU scheduler or the short-term scheduler, and it is given to the CPU for the execution. If it do not meet the IO operation, then it will go for termination. This is out. Now, if after the execution of this process, if the process needs the IO operation to complete, then it will give the IO request. IO request means a device, and then it will go to the device queue. We call it as an input-output queue. Then one of the process from the IO queue will be selected and it will be allocated to the IO devices and it will perform the IO operation. After performing the IO operation, if it has to again execute, then it will go to the ready queue. This is the first situation. Then second, if the operating system is working in a time sharing mode, then every process will be given certain time slice, fixed time slice, that is suppose 5 seconds are there. Suppose 5 seconds and the process need 10 seconds. Then if the 5 seconds are over, then time slices expired. Then in this case also the CPU will be taken forcefully from the process because 5 units of work has been completed, and then again the remaining 5 units of work will be completed in a second term. Okay. Then third, if this is a process which has created a new process called child process, then the child process should be executed first. So child process should be executed and then the execution of the main process, parent process, will be resumed. While executing, if any type of interrupt occurs, then it will wait for the interrupt. If the interrupt occurs, then the interrupt will be given the services and then after that again it will go to the ready queue. So this is the representation of the process scheduling. Then what type of schedulers are there? First one, we call it as a long-term scheduler. Now what is meant by the long-term scheduler? The long-term scheduler selects the job from which means this selects which process should be brought into the ready queue. Long term is this type of scheduler select the process from the hard disk, that is secondary memory, and then it will be brought into the those processes which are ready for the execution, this will be loaded in a ready queue. Then short-term scheduler. Short-term scheduler means what? Here, the process which are present in the ready queue, they are selected by the short-term scheduler. It is also called as a CPU scheduler, and it will be allocated to the CPU. Now this is just the example or the diagrammatic representation of this one. See, generally what happens here, this is a ready queue. In ready queue, the processes which are coming from the outside world are stored. Then it will execute. After the execution, if the process don't want to go for the I/O operation, that will end. But if it has to do the I/O operation, it will go to the I/O waiting queues. Okay, and then it will perform the I/O operation. Okay, and then after performing the I/O operation, it will again enter into the ready queue. Now, if the process has not been completely executed, it's a partial execution of the process, then this will be swapped out onto the hard disk. That is, partially executed process will be kept on the hard disk, and then again after some time they will be loaded into the main memory in a ready queue, and then it will be executed. Okay. Now the schedulers here, short-term scheduler. Short-term means these schedulers are invoked by the operating system frequently. So it is called it as a short term because the process requires very minimum amount of time for the execution. So the short term scheduler has to perform its work very fast. So it is very frequently. Then long term scheduler means it brings the program from hard disk to the primary memory. And you know that whenever you are copying the file, then it needs more time. So long term scheduler is very infrequently, so it will be slow. And then the long term scheduler controls the degree of multiprogramming. Degree of multiprogramming, as I have told earlier, that the degree of multiprogramming means the total number of programs which reside in a main memory. And this long-term scheduler brings the program from secondary memory to the primary memory, and from primary memory to the secondary memory. So it controls the degree of multiprogramming. Process can be described as either the I/O bound process, and the second one is the CPU bound process. Now what is meant by the I/O bound process? I/O bound process means the process which has been bound to the I/O devices for a long time. That is, it spends more time doing I/O operation. And the CPU bound process means the process which spends more time on the CPU, that is a CPU bound process. So this CPU bound process means having very long CPU burst time, and I/O bound means it is having a long I/O burst time and short CPU burst time. Now what is the context switch? Now context switch means when the process switches from when the CPU switches from one process to the another, then the system must have to save the state of the old process and load the saved state of the new process. So context switch means the jumping of CPU from one process to the another process. Suppose that the first process is executed completely. Then this process should be removed from the main memory, and the CPU has to jump to the second process. Means it has to load the saved state of the new process. This time is called jumping from one process to the another. It is called context switch. Okay. So context switch time is overhead. The system does no useful work while the switching. Whenever the CPU is switching from one process to the another, then it will not do any type of work. So what happens? It is dependent on the hardware support, how fast it is. If the advanced hardware is used, then the CPU can jump fast from one process to the another. Now, what is the process creation? Now, see, there are two processes. One is a parent process and another one is a child process. Parent process means a main process, just like consider that you are writing a C program. So you start with a main, okay, and then you write down the code. After some lines of code, if you are trying to call a function, okay, so for that function, the another process will be created, and that is called as a child process. So parent process create children process, which in turn create other process, forming the tree of the process. Now, resource sharing. How the resource is shared between the parent and the child? The parent and the children share all resources. So it may be a memory, it may be I/O devices, it may be stack and so on. And sometimes the children share the subset of parent resources. Means they do not share all the resources of the parent, they share the subset of resources. And there may be a situation that the parent and child do not share any type of resources. Got it? So resource sharing means what? Means how they share. Sometimes they share all the resources, sometimes they share the subset of resources, and sometimes they do not share any type of resources. Then the execution. Sometimes the parent and children execute concurrently. Sometimes the parent has to wait until the children execution. So when the children execution is completed, after its termination, the parent will start executing. So this is about the execution. Got it now? So process creation means the parent process create the children process. How the resource sharing is there, how the execution is there. Now address space. Sometimes whatever the address space of the parent is there, its duplicate copy is made, and that duplicate copy is given to the child process. And the child has a program loaded into it. In Unix, what happens? A fork system call is used to create a new process, fork. And the exec system call use after a fork to replace the process memory space with a new program. So exe means for the execution and fork means for creating the new process. Process termination. Now how the process termination takes place. The process termination takes place in a Linux or the Unix with the exit, exit. Process execute last statement and ask the operating system to decide it whether to exit or not. Now the output data from the child is given to the parent because the parent is waiting for the child. So it is given to the parent, and the process resources are deallocated by the operating system. When the child gets terminated, its resources, whatever the resources has been allocated, they are deallocated by the operating system. Now, the parent may terminate the execution of the children process. Means, and unless waiting for the child to terminate by itself, sometimes the parent forcefully terminate the execution of the children. We call it as a abort, just like the abortion. Okay. So abort is there. Child has exceeded allocated resources because why it aborts it randomly? Because the child is trying to access the exceed number of resources. Okay, and take assigned to child is no longer required and the parent is exiting. In these such cases, the parent forcefully terminate the children process. When the child has exceeded the allocated resources and the task assigned to the child is no more required because the task of child is completed, and in the third case when the parent is exiting, then it has to abort the children. When the parent is exiting, the operating system does not allow the child to continue if its parent terminate. Okay, And cascading termination means first children, then second children, then third children, fourth children. We call it as a cascading termination, that is one by one termination. Now what is meant by the cooperating process? See, there are two types of process. One is an independent process and the another one is a dependent process. Independent process means what? They are not dependent on each other. Independent process cannot affect or to be affected by the execution of another process. And cooperating process means what? They can affect or be affected by the execution of another process because they are dependent, they want to cooperate. Now, what are the advantage of process cooperation? Just like you are living in a society, so if you people are cooperating to the other people, just like in operating system environment, the processes are there, multiple processes are there, and if the processes are sharing the data or the information, they are cooperating each other. Then what should be the advantage? Advantage is that information sharing, they can share the information. Then due to this, the computational speed up can be increased and the modularity can be increased. Okay, modular means it will become simple and the convenience means it becomes convenient for the process to reach to the other process to share the information. Then the producer consumer problem. This is just one more interesting example which is generally used called producer consumer problem. Producer means the process which is producing and consumer means which is consuming. Consider that you are typing something from the keyboard. So who is producing? Keyboard is a producer. So keyboard process is a producer process. And these characters are appearing on the screen or the monitor. So who is consuming? Monitor is consuming. So monitor is called as a consumer process. And this keyboard and monitor, they are cooperating each other. They are sharing the information. So we call it as a producer-consumer problem. Now where this shared information is kept, it is kept in a buffer. So there may be unbounded buffer which is place no practical limit on the size of the buffer, and another one is a bounded buffer means there is certain fixed buffer size. Okay, so this is all about the that is a cooperating process, and this inter-process communication we will see in the next lecture. Thank you.